Good. Then welcome everybody to our next meetup about Canonical Distribution of Kubernetes with Tim Van Steenburgh. Thank you, Tim, for providing us this great session, and I hope that all of us, and I'm very sure we can learn from you and related questions with to Certified Kubernetes exam, Administrator exam. And yes, I let you introduce yourself, share your screen, and if there is any questions, please write into the chat or unmute yourself or and ask the questions at any time. Thank you very much. So. Okay.
Yeah, thanks, Arash. Thanks for having me. Happy to be here. Excited to do this. I'm going to go ahead and share my screen. And so welcome everybody. Hello, my name's Tim Van Steenburgh. Like Arash said, I'm the Kubernetes engineering manager at Canonical. And the objective today is to talk about Canonical's distribution of Kubernetes, what it is, how you can use it, how it relates to the CKA exam that we all want to take and pass. So we'll kind of take a meandering tour through a bunch of different topics. We'll do some demos, click through to a bunch of things, and just kind of take a closer look at what the Canonical Distribution of Kubernetes is. So that said, before we do anything, I'm going to start off with a demo right off the bat. So hopefully this text is big enough for everyone to see. What I have here is a brand new booted Ubuntu Xenial VM in AWS. So I just booted it right before this meeting. I haven't touched it yet. And what I want to show you is how to deploy a canonical Kubernetes, a full Kubernetes cluster on one machine using LXD containers. And I haven't done any pre-setup, so you'll see exactly what I want to do or need to do to get this working. The first thing I'm going to do is I'm going to upgrade LXD because I know that this VM comes with LXD from the apt archive. Let me make sure. Can somebody just confirm that you can see my screen and hear me and everything okay?
I can see your screen and I can hear you.
Okay, thank you.
You're welcome.
So I know that this version of LXD is a little bit out of date. So I'm going to go ahead and remove this because I want to install a newer one. And instead of going from the apt archive, I'm going to snap install LXD because I know with the snap package I can always get the latest and greatest. Okay, so we have 2.18 now, and we see we have the snap version of LXD. Incidentally, you don't have to do this. You can use the older version of LXD. It'll still work. I just like using the newer one. So you run LXD init just to initialize stuff real quick. So storage pool, yes, we want a storage pool. Default name is fine. We're just going to use a directory storage pool. We don't care about LXD being available over the network. Cache images is fine. Yes, we do want a new network bridge, and I'm going to call this one, let's see, LXD BR1. IPv4, auto is fine. For IPv6, we're going to turn this off because I know that Juju doesn't play nicely with IPv6 quite yet. Okay, so we've got LXD configured, and we're in the LXD group, so now we're ready to go. And what we want is we're going to install, again, from the Snap store, Conjure-up. And I'm not going to go into what Conjure-up is exactly right this minute, but we'll come back to that in a little bit. So by the way, while this is installing, if you guys are typing in the chat questions, I can't see the chat channel or window right now because I'm on a different screen, so please feel free to interrupt via your microphone if you want to ask anything. Okay, so we have Conjure-up installed. Now, Conjure-up Kubernetes. Okay. For the people who hate GUIs of every kind, including ncurses-based terminal GUIs, you can run this in headless mode if you want to, but I'm going to do it in the GUI mode just so you can follow along more closely with what we're actually doing. When you conjure up Kubernetes, you have two choices. You can do the full canonical distribution, which is the scaled out cluster. It has multiple workers. It's basically a 9-node cluster. Kubernetes core is a very trimmed down Kubernetes with one master, one worker, some components deployed onto the same node to save machine. So we're going to go ahead and do the canonical distribution. So we just hit enter here. We're not going to do any add-ons, but you have the option of, hey, when my cluster is stood up, go ahead and install Deis on it, for example, or go ahead and install Helm for me because I know I'm going to be deploying Helm charts. We're not going to do that. We're just going to continue. Now, you'll see Conjure-up asks us, where do you want to deploy this cluster? And we have a whole bunch of options here. AWS, Google, Azure, Oracle, Rackspace, MAS if you've got a bare metal cloud, vSphere if you're running VMware. For this little demo, we're going to choose localhost because I want to show you how to deploy a whole cluster onto one machine. We're going to pick our new network bridge, default storage pool, and then sudo password and enter. Okay. Now this is the final confirmation screen where Conjure-up saying, okay, this is what I think you want to deploy. You can see we're going to deploy 6 different applications: EasyRSA, etcd, Flannel, a load balancer for the API server, a master, and a worker. And the worker, we're going to deploy 3 units of the worker and 3 units of etcd. You can configure these differently, but for the purposes of the demo, we're just going to accept all the defaults and go ahead and deploy.
Hi, this is Arush.
Yes, go ahead.
Yes, I just wanted to know, so in the default setting, the only networking CNI plugin that's available is Flannel. Is there any way through which we can use some other networking plugin to be more specific, as in case of the CK exam, the lab setup? So for one of the clusters, Calico was used. So how we can use Calico or any other networking plugin?
Yes, you absolutely can. If we have time at the end, I'll show you how to do that. We do have a bundle that deploys with Calico instead of Flannel. We have current work in progress that will add that to Conjure-up, so you can just select Flannel or Calico when you deploy. So we haven't finished that integration yet, but that'll be coming soon. And in the meantime, there's a way to deploy that bundle without using Conjure-up. So I'll come back to that at the end if we have time. So I'm gonna, while this, flip back the slides now while we wait for that. And the first part of this presentation is just to explain what the canonical distribution of Kubernetes is. Kubernetes is really popular right now, obviously. There's a lot of Kubernetes stuff out there. There are different distributions. There's Tectonic, there's OpenShift, there's Canonical. And I think it's important for people to know, especially technical people want to know, okay, what exactly is the canonical distribution of Kubernetes? You might even be concerned, well, why would I deploy the canonical distribution of Kubernetes when I can just deploy the real Kubernetes from Kubernetes? So the first thing that I want to point out and clarify is that when you deploy the canonical distribution of Kubernetes, you are getting the exact same upstream binaries that you would get if you downloaded them yourself from the Kubernetes repo after a release. That's in fact what we do. Give me 1 second, please. I need to handle an audio problem. I'll be right back. Okay, I'm back, everybody. Sorry about that. But yeah, pure upstream Kubernetes binaries. We don't modify the binaries in any way. So when you deploy the canonical distribution, you're getting the same binaries that you would get if you, for example, took the binaries yourself and created your own cluster from scratch. Exact same bits. What the canonical distribution gives you is a super easy way to get all of those bits configured, deployed, and talking together. So that's the first point. And like I just mentioned, and you saw on the Conjure-up installer screen, one of the benefits of the canonical distribution is that we can deploy pretty much anywhere. All the major public clouds, private clouds that are using VMware or MAS, MAS on bare metal, LXD, and just for those who may not be familiar with LXD, I would encourage you to check out linuxcontainers.org. You can read more about what LXD and LXC are. LXC has been around for a long time, and it's the actual container. And I think the best description of what LXC actually is right here in the middle of this page. The goal of LXC is to create an environment as close as possible to a standard Linux installation, but without the need for a separate kernel. So it's not a VM, it doesn't have its own kernel, but it's not as bare as like a Docker container where you're basically just one process running. We like to call it a system container. And then LXD is the hypervisor that manages all of those containers. So with the Conjure-up distribution of Kubernetes, you get this nice LXD integration where you can do what we're doing over here, which is deploying a full cluster onto one host using LXD containers. Okay. What else do you get with the canonical distribution? You get automated operations. So what do I mean by that? So scaling operations, let's say you want to add another worker or another 5 worker nodes, another 10 worker nodes, or you want to scale back. That just works for you. You can just literally add unit Kubernetes worker and you will get a fully configured new worker node added to the cluster. And we'll look at that a little bit. Actually, let's look at that now. I might as well show stuff while I'll do demos throughout the presentation instead of saving them all for the end. So this is the one that we're deploying right now. This is one that I deployed in the same way to a different Amazon machine that I booted up. So this is the end result. And you can see we've got EasyRSA, etcd, Flannel, and all of our Kubernetes components here. You can see we're on version 1.7.4 in this cluster. And you can see at a glance, like all the green stuff generally means that things are working properly and as expected. So if I wanted to add a new worker to this cluster, I can say Juju add unit Kubernetes worker. And you see immediately we had worker 3 pop into our status output here and begin to allocate. So that's LexD provisioning the container. And once the machine container comes up, then the components for the worker will be installed and configured. So we'll keep an eye on that. What else do I mean by automated operations? One of the big things is upgrades. How do you get from, for example, you're on Kubernetes 1.6.2 and Kubernetes 1.7 came out. Well, how do you upgrade your cluster? And that's another thing that the canonical distribution makes very easy for you. So this is another LexD cluster. And actually, I was playing with this earlier, so you're going to get to see both sides of this demo. I'm going to downgrade the master first. Actually, you see up here, I've got a master running 1.7.4 and a worker running 1.6.2, and that works because the API server is backward compatible with older versions. But what I said here was, hey, I want to go ahead and change the configuration on the Kubernetes master and tell it to use the binaries from 1.6 stable channel. And in our status output up here, you can see that stuff is happening. It's reinstalling the binaries on Kubernetes master to get the version that we want. Let's see how our add unit is doing. Okay, so you can see our Kubernetes worker 3 is still doing stuff. It's in the installation phase, so it's installing the software for the Kubernetes worker. And over here, we've got still activity going where we're in the process of downgrading our master from 1.6.2 to, or from 1.7 to 1.6.2. So we'll check on those. I'm thinking this is about to finish, so I don't want to flip away. Any questions so far while we're watching?
Yeah, I have a few, but I guess I'll save it for the end of the whole session because that's
okay. Yeah. No problem. That's fine. Well, we'll give that one more minute and go back to slides. So that's what we mean by automated operations. So it's scaling, it's upgrading, and we'll do more on the upgrade in a moment. But it's other things too, like we have actions built in for setting up a private Docker registry, for coordinating and draining nodes if you want to move pods off of one node to another. For doing persistent volume provisioning for Ceph. So lots of different built-in automated operations that come with the canonical distribution that are kind of on top of the base Kubernetes. Okay, come back to our demos in a minute.
Tim,
so,
yeah. Question in the chat. Valid ask, I missed the beginning. So are you using LXC for your containers or Docker now? It was LXD, right?
Okay. Let me see. Let me opening the chat. Yes. So the system containers that are running the Kubernetes components, those are LXC, LXD. It's a little bit confusing because the container itself is LXC, Linux container. LXD is the hypervisor thing that manages those containers. But yes, so we're deploying the cluster components into LXC containers. And then, of course, you have your Docker containers running inside of those for pods. Okay. Let's see. So here on our new worker, we see we're still making progress here. It's installing Docker.io from Universe. The demo gods are frowning on me right now. I'm trying to figure out why my master has not updated to 1.6.2. But that's okay. I don't care about that too much for the purposes of this demo. What I wanted to show was how my workers are on 1.6, and I can tell them upgrade. Oh, there we go. It just updated. Okay, see that? So our Kubernetes master, I'm actually glad that happened. Kubernetes master, Kubernetes worker, they're both on 1.6.2. So now, to do the upgrade, I want to do the master first, because otherwise if I do the workers to 1.7, the API server won't know how to talk to them. We'll do that, come back in a minute. But let's plow forward. I've kind of decided what you get with the canonical distribution, but it's still, I'm sure for a lot of you, still very opaque. Like, okay, you've painted a rosy picture of what you get with it, but how does this stuff actually work? To say that you can run equally well on all of those clouds is a pretty bold statement. How can you actually ensure that you can run on all of those clouds and still keep up with the upstream distribution of Kubernetes? So we're going to go a little bit deeper, talk about how the sausage is made, what is the underlying technology behind CDK, how does it really work? And in one word, it's Juju. So the canonical distribution is built on top of Juju, which is an open source, 100% free and open source project that allows you to model simple to complex topologies of interconnected cloud software. So it's not just for Kubernetes. It's for any solution that's distributed that you wouldn't deploy on a cloud. So we use Juju for our OpenStack solution, which happens to be one of the best out there and keeps up with upstream fantastically well. For our big data solutions, we use Juju, and so we're using Juju again for the canonical distribution of Kubernetes. The point being that you should know that when we talk about the canonical distribution of Kubernetes, it's not a huge, complicated project that has lots of moving parts that have to, have all these little subtle ways to work across many clouds. We get all of that for free because of the fact that we're using Juju underneath. So it's Juju that gives us the automatic scaling. It's Juju that gives us the ability to deploy on any cloud. So that's kind of the foundation layer of CDK. So with that said, what is it that is what is CDK on top of Juju? This is a picture of what it looks like. It's a bundle of software, and the CDK bundle happens to include these components that we've already looked at, these 6 components. We have our master, we have a worker. In a multi-master situation, we have an API load balancer. We have etcd for storage. We have Flannel for our container network overlay, and we have EasyRSA that does certificate generation and passes certs out to the cluster components so they can talk over TLS within the cluster. So now you might look at this pretty picture and say, you know, that's a really pretty picture. It still doesn't really tell me what's going on underneath. Like, how does this really work? So what I wanted to show you is if we go to jujucharms.com/canonical Kubernetes. And I'm going to show you exactly what this picture represents. Click on this bundle.yaml file. This is deploying. When you deploy CDK, it's this bundle file, and you'll recognize pieces of it. Don't worry about the annotations. This GUI stuff is just for making it look pretty when you make it a picture, but you'll see all of our components in here. You'll see how many units of those things we want. You'll see right here, okay, if you deploy this by default, you're going to get binaries from the 1.7 stable channel. You'll see that by default we're saying, hey, we want all of our workers to have 4 cores and 4 gigs of RAM. And then you'll see at the bottom how all of these components connect together. So the next thing you would logically ask is, okay, it's a bundle file, but I see for your Kubernetes worker, it's pointing to this weird looking thing. And that weird looking thing is a charm store URL. So if you think of it like an app store for cloud software, what this is saying is, hey, when you deploy this bundle, grab the component for Kubernetes worker from this URL. So I'm going to go back to see, actually, that's not what I want to do. To simplify, I'm just going to, let's see, Kubernetes worker. So go to the charm store and Kubernetes worker. What I'm getting at is I want to find how deep does this go? Where can I find the actual code that's getting run when I deploy CDK and it has a Kubernetes worker? So here we are, Kubernetes worker. And if you look at the files over here, you're gonna see that what a charm is when we talk about a bundle of charms. A charm is just code in a directory that Juju puts on a machine that it's provisioned. So to go even one step further, okay, here's all the code for the charm. Well, I want to actually look at that code. So let's go to a repo that I'm sure you're all familiar with, upstream Kubernetes. And if you go in the cluster Juju directory, layers, and here's our worker. So when you deploy a worker with Juju, this is what's actually going onto the machine. And I'll show you just how simple it is. Now, you know, I'm hand waving a little bit here because obviously this tree has more code in it than just one file, but this file here is the guts of the Kubernetes worker. So if you want to know what's happening when you deploy and what's going on with that worker, this is it. It's a 900-line-ish Python file. So we looked at the bundle of software components. We've talked about what a bundle is. It's a collection. We talked about what a charm is. It's just code in a directory. And what happens when you deploy a bundle of charms with Juju is, depending on what cloud you're deploying to, it knows how to provision the underlying machines. So if you're going on AWS, it knows to provision EC2 instances. If you're using LXD, it knows to provision LXD containers. Once it's provisioned, it takes that charm code that we just looked at, and it dumps it onto the file system of that machine that it's provisioned. And then it starts executing code in that charm directory in response to lifecycle events that are happening in the cluster. So the Juju API server is talking to each of those machines and telling it, okay, your machine is totally done provisioning now, so you can go ahead and install. And it will run the install hook, and it will execute the code in your charm that does the installation bits, like putting binaries on disk. And before I go too much further in that, just fast forward to this slide, which will be helpful. So what does the charm do? It handles installation. It handles configuration. Coming back over here, this would be a good time for us to see that our master is on 1.7.4 now. Our workers are still on 1.6.2. So when we talk about configuration, this is what we mean. Any charm, you can say, every charm provides some configuration that you as the operator can set. And in this case, one of the configuration options that we can set on the worker is to say, hey, I want to change your channel to 1.7 so that I can upgrade you. And we'll check on that in a minute. What else? Connections. So we saw in our bundle file over here, we define all these connections of how the software should be connected together. And it's more obvious in the picture. You can see the lines, how everything is connected together. So the charm has code that knows how to react when Juju says, hey, Kubernetes master, a new worker just connected. So charms handle those connections of other components. They handle upgrades and updates, like we've already seen a little bit, the scale out and scale back. Let's take a look at what's going on with our, so this is the one where we did Juju add unit Kubernetes worker. And now we can see after some time, our worker 3 has been added to the cluster. It's up and running. It's got Flannel overlay installed. It's got its IP address on the Flannel subnet, and the worker is running and operational. And other operational actions. So that's some of the other stuff that we talked about, like provisioning, storage, taking a snapshot of etcd, doing a restore of etcd, any other operator-driven actions that you might want to perform on a charm are encapsulated in the charm code itself. Now, this is our upgrade cluster. So you can see that I said, hey, workers, I want you to upgrade to 1.7. And you can see they went into a block state. And why is that? It's because the code in the charm was written so that we don't want to automatically upgrade you to 1.7 from 1.6. We want you to be say, I want to do an upgrade, but then manually control which nodes upgrade when. So in a production scenario, what you might do here is you've configured for the 1.7 channel. You would probably add, in this example, you would add 3 new workers. So Juju add unit -n, well, it would look like this. I'm not going to actually do it, but Kubernetes worker. That's what it would look like. So you would add 3 new nodes. Those would come up on version 1.7. Then you can cordon and drain your existing workers so that all the pods will be reassigned to your new workers. And then you could just tear down your old workers that are on the old version. If you're exceptionally brave or you're doing a demo, you can also just say, you know what, I don't care about doing a blue-green upgrade. I'm just going to upgrade everything in place because I'm a cowboy. So we can say Juju run action unit Kubernetes worker 0 upgrade. So I don't need unit. Okay, and it tells me it queued up an action. Let's see what happens with that one. Okay, there you can see stuff is starting to happen there. It's installing a new version of kubelet. So I'm just going to plow ahead and I'm going to run that upgrade on my other two workers. And we'll come back and check on that in a minute. Let's go check on our thing that we deployed. So this is the one we deployed right at the beginning of the presentation where we have a brand new LXD cluster, and you can see it's still configuring itself. So we'll keep an eye on. Okay, and it's already done. No, this is this one. Let's see. Okay, we'll check on that in a minute. So that's more into the guts of how CDK actually works. And I don't know how interesting that is to this crowd or not, but I think it's interesting I think it's valuable for folks to know what's going on under the covers, because if you don't, then I think there's a tendency to be more resistant towards it because you don't actually know what's happening. Like, well, canonical distribution, I'm not really sure how that works, so I think I'm just going to grab binaries from upstream and roll my own cluster. But it's actually a very simple setup using the upstream binaries themselves. Okay. So we've talked about CDK, Juju. What about Conjure-up? We haven't said anything about Conjure-up. You're talking about Juju a lot, but at the beginning of the presentation, you ran Conjure-up Kubernetes. So how does Conjure-up factor into this story? So Conjure-up is simply, it's an installer that drives Juju. So you can deploy things with Juju by itself. So instead of doing Conjure-up Kubernetes, you could do Juju deploy canonical Kubernetes. Juju is very good at taking a desired state, like the file that says, I want you to make a deployment that looks like this, and here's the YAML that describes it. That's what Juju does. It takes expected state and it turns it into the actual state. So it's not really imperative. We have the capabilities for doing imperative operations, like, for example, upgrades, but they're operator driven. So with Conjure-up, what we have is a way to drive Juju and then do other stuff that Juju doesn't necessarily do for us yet. So Conjure-up's talking to the Juju API to tell it what to do. And so what are some of those things that Conjure-up lets us do that Juju isn't doing for us yet? One of those things is native cloud operations. So far we've been looking at LXD clusters, but I also deployed just before in the same manner using Conjure-up. I said Conjure-up Kubernetes, and instead of picking localhost, I chose AWS. So you can see at the top of our screen here, we have a deployment in US East 1. It looks identical to our LXD deployments because it's the exact same components. They're just deployed, instead of on LXDs, they're deployed on EC2 instances. So we can even look over here at my AWS console, and you can see all these running machines. And if we took the time to match up the instance IDs, you would see that they match. So all these instance IDs for these machines are what's running in that AWS cluster. So where were we? Shows that what Conjure-up lets us do is when you deploy on AWS, for example, well, if you're deploying Kubernetes on AWS, you want to get the extra things that AWS provides, like an elastic load balancer or elastic block storage. Juju, one of its strengths is that it abstracts the clouds away so that you can just write your software and know that Juju can put it on any cloud. But what happens if you want to know what cloud you're on? So that you can use native cloud extras. So that's one of the things that Conjure-up allows us to do. So what we'll see is that when you conjure up Kubernetes to AWS, Conjure-up, of course, knows that you're deploying to AWS. So it will do all the stuff that you need to do in order to enable those native cloud integrations. So it will create the IAM policies and the IAM roles, and it will assign them to your nodes, and it will create the Kubernetes cluster tags on your security groups, and it will go into your cluster binaries, the API server, the kubelet, and it will set for you cloud provider equals AWS. So once your your cluster comes up on AWS, you have all the native cloud integrations available to you. So to show what that looks like a little bit, we have an example in the Conjure-up documentation about this. So Kubernetes and AWS CNI is not such a great choice of a name. They mean cloud native integration, but it's easily confused with container and network. But I digress. So what we're going to do is we've got a cluster on AWS. So let's see if we get our ELB. So on our cluster, we're going to run 5 pod replicas of the Hello World image. Okay. And just do some Kubernetes stuff. So, okay, we're already all up and running. We got our pods and they're all running. So let's see what we do next. Okay, so we want to expose that deployment with a type of load balancer. Okay, and then we'll say kubectl we want service, get service hello. That's what we want. Okay, it's already done. So when we deployed, we deployed that load balancer, we got an Amazon ELB because Conjure-up had already turned on the native cloud integrations for us. So if we take this URL, and it was port 8080. It's a minute for DNS to propagate, so we'll come back to that in a second. So native cloud operations, Conjure-up does that for you. Client-side operations. So if you remember the first LXD cluster that we launched with Conjure-up, it asked us at the very beginning, hey, do you want to install Helm? So that's a client-side operation. You would get the Helm binary on your local system so that you could drive your cluster using Helm, deploy Helm charts, etc. So Conjure-up lets us do that. Obviously it installs kubectl for us when we deploy a cluster. And then imperative operations was the other example. So if you wanted to say, hey, I want a Kubernetes cluster, but I want to go ahead and install some sort of add-on on top of it, when it's stood up, like Deis workflow, then you can do that too. So that's how Conjure-up fits in. It lets us add on some really nice stuff that we couldn't do with Juju natively yet. See if our ELB is reachable yet. I have faith. I'm sure it'll come online eventually. We'll keep going. Okay. So that's all about CDK, what it is. But one of the topics for this talk was to talk about how CDK relates to the Certified Kubernetes Administrator exam. So let's talk about that a little bit. In short, Linux Foundation came to us to help them build out the infrastructure for the CKA exam using CDK. And one of the reasons that they did that is because of our cross-cloud compatibility that we get with Juju. It's, as you saw, it's super easy for us to deploy LXD clusters of Kubernetes. And the reason that's important is because for an exam scenario, you want to deploy lots of different clusters in lots of different pre-configured scenarios, but at 9 nodes per cluster, you don't want to be spinning up 50 Amazon EC2 instances for every person that's taking the exam, obviously. So what you get with LXD is this hyper-dense deployment where you can have not just one LXD cluster on a machine, but you can have multiple LXD clusters on a machine, which is exactly what they wanted. So for the CKA exam, what you actually have underneath is one host. So it's one EC2 VM that gets spun up for your exam. And on that host are 6 Kubernetes clusters, and they are provisioned using LXD. And since each is 9 nodes, then you have basically 54 LXD machine containers running on that one Amazon instance. And all of those are pre-configured by the Linux Foundation for the exam to be in different states of health or brokenness. And it's your job in the exam to operate on those clusters and carry out the actions that you need to for the exam. So repairing things or debugging, stuff like that. Disclaimer, I have not taken the CKA exam. I plan to. A couple of guys on our team have taken it and passed it. They said even the guy on my team who helped with a lot of the infrastructure setup for the Linux Foundation, said the exam was really hard. So I don't know if anybody on the call has taken it. I'd be interested if anybody would say the exam was easy.
Just as a correction, there are 8 Kubernetes clusters, not 6 for the exam.
Okay. Thank you for that. Have you taken the exam?
Yep.
And was it hard?
Definitely.
Yeah. Okay.
It's at least a 9 or 9.5 on a scale of 10 for hardness.
Yeah, that's what I've heard from everybody so far. But I like that because it means that if you pass the exam, it's worth something. It's got some value, so I'm okay with that. But thank you for the correction on that. And let's see. So we have all these LXD clusters set up. Then what they did was after everything was set up the way they wanted for the exam, they baked it as an Amazon machine image, took a snapshot of it, stuffed it into AWS, and then they can deploy, you can spin up that AMI for each exam participant to operate on all of those LXD clusters. So that's how the CDK relates to the Certified Kubernetes Administrator exam. Let's go back and see. Yes, we were waiting for our ELB to come up. Okay, and it finally came up. So there we are with our Amazon load balancer proxying traffic through to the pods in our Kubernetes cluster saying, hello, Kubernetes. Okay, now it's time to do any demos that I haven't already covered yet. Let's see, let me just flip through these and see where we're at. So we got our master and our workers all upgraded to 1.74 here. This is the cluster where we showed scaling. So we did an add unit. We can also do a remove unit. For remove unit, you would tell it exactly which one you want to remove. So we'll remove the third one. This cluster is the one that we launched at the very beginning, taking forever to spin up, and I blame AWS. Normally, so with the LXD deployment, one of the awesome things about it is you can just do it on your laptop and have a fully self-contained Kubernetes cluster running in LXD on your laptop. That's what I usually do. I didn't want to have a bunch of clusters running on my laptop for this presentation because I was afraid that it would, everything would be laggy with the screen sharing and everything like that. So I've done blog posts and videos of this before where normally on a laptop, this will take about 10 to 12 minutes to completely stand up and be ready to use. Okay, let's see, what else? I have some cheat sheet here to see if there's any other demos I wanted to show. The dashboard. We can do that. So this is our Amazon cluster, and we can see, okay, the load balancer. Well, let's just do this. kubectl cluster info. So we see the master is running at this address, which is actually our load balancer that's proxying back to our master. That's so that we can add extra master.
We lost your screen.
Oh, okay.
Could you please share your screen again?
Okay, yeah. Okay, how's that? You see me now?
Yes, we see your screen, thank you.
Okay, okay. So we'll take here's our master. Here's our master, and we're going to get an UI for the dashboard. And there we go, and we can see those Hello World pods that we spun up are in there. We can see, if we look at our Amazon console, we'll see the load balancer that was created. Eventually, right? There we go. So there's our load balancer. What else can we show? We did the ELB. We did an upgrade. We did scaling up and scaling down. Pausing. Let's see. Do a pause. So on our Amazon, we have kubectl get pods. Okay. we have all these. I actually want to watch that so we can see it change. Actually, I'm not going to do it on this cluster because there's a little bug that I found preparing for the demo. So I'm going to do it on one of our LXD clusters. So what I want to do is take our, where was our documentation for deploying all those pods. Let's get that back. So I want to run this again, only this time I want to do it on LXD cluster. We'll watch those and make another screen. So we'll watch those pane. Then so you can see if you look here, these node names correspond to the machines that the pods are running on. So we have our default HTTP backend is running on machine 9, and then we have 3 pods running on machine 11, and we have 2 pods running on machine 10. So what we want to do is we want to know which is machine 10. So machine 10 is Kubernetes worker 1. So we want to say Juju action Kubernetes worker 1 pause. And so this is one of those imperative actions that we talked about that you can define in your charms that are kind of like helpers for things that you know an operator might want to do on the charm. And so if the demo gods cooperate, what will happen is the pause action is basically a shorthand for I want to cordon off this node and I want to drain all the pods, and then we would see the pods that I meant to be watching here. We would see them move off of 10 and move on to another node. It might take some time. We'll see how that goes. Let's see. What else for demos? I think that's all the demos I had, but oh, so somebody early on asked about alternatives to Flannel. So we don't have that built into Conjure-up yet, but what I can do is I'm going to switch to my hosted model or my hosted controller in Juju, and I'll show you real quick how you can deploy, for example, a cluster with Canal. So you would okay, I need to tell it AWS. Okay, so we have a new model to deploy in, and then we can just say Juju deploy Instead of Canonical Kubernetes plain, Canonical Kubernetes canal. Incidentally, while I'm doing this, I mean, it occurs to me that it seems perhaps like a lot of moving parts. What I recommend for people who want to get or are interested in canonical distribution of Kubernetes to get started, all you really need to do is install Conjure-up. It will install Juju. It will prompt you to install LXD if you don't have it installed already. And you can be up and running just with Conjure-up. And then what happens is you get your cluster up and running, and then you want to learn more about what you can do with it from a Juju perspective, and the stuff that Juju gives you, like easy SSH into the units, scaling, upgrading. And that's when folks tend to dig deeper into the Juju side of things and kind of uncover all the hidden power that's there that you can also use. So I know it seems like a lot of pieces, but you don't have to be intimidated. There's a very easy on-ramp, and then you can just continue to dig in as you feel comfortable and learn more. So you can see Juju by itself, you Juju deploy, you don't get the graphical interface that you do with Conjure-up. It's just a straight command line. However, since I'm using my hosted controller, I could go to jujucharms.com and I could log in as me. And of course, I get two-factor auth for the demo. Let's see. So before I explain, I keep saying hosted controller. I want to make sure people understand. When you use Juju, normally the first thing that happens when you deploy, you need a controller. That's the Juju API server that's running and talking to all of your units. But if you don't want the overhead of that extra machine running the controller, you can use our hosted controllers. It's Juju as a service. You can read more about that at jujucharms.com, but that's what I'm doing. So I already have access to the hosted controller, so I can spin up a new deployment without having the overhead of an extra machine for the controller. Because I've done that, when I log in to jujucharms.com, it shows me the models I have running, and you can see here's Canal, the Canal model that I just created. And if I click Manage, and wait a second, it's going to show me, this is a GUI view of exactly what's being deployed over here. And in fact, the initial deployment is done. So now we can watch the status of that on the command line, and you'll see it looks very similar to the other clusters that we've been playing with. So that's the command line view, and then you have this GUI view over here as well. You can actually manipulate the model from the web browser as well, changing configuration on units. The full power of the Juju command line interface in the GUI form. So that's the Canal bits. Basically, TLDR is if you want to use Canal today, you would just Juju deploy it directly. But we're already working on adding that into Conjure-up as an option that you can choose. So that'll be coming very soon. So it's been about an hour. I think I'm out of demos, but I am definitely open to questions now, if people have any.
So in the chat, I have sent you a list of questions that people have asked over time in the common chat. whole complete compile list of that. If you go back, not in the everyone chat window. Yeah, just click the
Okay,
arrow.
okay.
Yeah, the last one.
The
Arrow.
the
No,
last one. Okay.
arrows.
Okay.
So sorry about the mess text, but each pound or the hash sign actually represents one question.
Okay. I'm on my way there. I was just turning off screen sharing. Okay. Is there any added advantage of running Docker or pods inside LXC? Okay. No, not really. It's just in the LXD scenario, you basically think of the LXC is your machine. It's your instance, it's your VM, however you want to think about it. It just happens to be itself a container. So it's not really an advantage, but what to do is, I find that LXD, you're not going to deploy the LXD in production, but it is awesome for spinning up clusters quickly to play on, to experiment, to do development work, testing. I use it a lot for that. It's a really good use case for LXD. Does this approach support cluster federation over multiple clouds? Yes. So I felt that federation was a little bit outside the scope of. Oh, I stopped sharing my screen. But let me paste a link in chat. Let's see. I'll paste this in the everyone. This is a blog post that one of the guys on my team did about doing federation with CDK. The short answer is, because we're just using pure upstream Kubernetes, you can do whatever upstream Kubernetes can do, including federation. And there's that blog post was written when we were on 1.6.2, I believe, was the current stable. We haven't really done much federation work since then. I anticipate that at some point we will do more work around federation to make it easier to set up. But there's nothing stopping you from doing federation with CDK today if you're willing to do the manual steps, which they were documented in that blog post, so that would be a good starting point for anyone who's interested in doing federation. Okay, I think system infra is LXC, however, app pods are Docker. That is what I understood. Yes, that is absolutely correct. It's Docker pods running inside of LXC containers. What is the additional storage, networking performance overhead of this container inception? Yeah, that's a good point. I don't have numbers for you, but I would refer back to my previous point about the primary use cases for the LXC deployment of Kubernetes. If you're doing it, you're probably not doing it in production. You're doing it for quickly standing up clusters to test or develop on or play with. So in my my experience, this isn't like with measurements and data, but just in my experience of deploying lots of Kubernetes clusters on LXD, I don't notice any prohibitive overhead of the container inception. How to get Kate's beta version? Yes, so we could improve here. What I would like to show, let's see. Oh, I got to share my screen again. Okay. Screen sharing, so actually remember. I shouldn't have shared my screen before I tried to remember what commands are. Aha, I guessed right. So you can see here, you remember when we were upgrading, downgrading, and changing the channel, we were saying Juju config Kubernetes worker channel equals 1.7.stable, and you can see that's got 1.7.4 in it. Edge has 1.7.6 because we haven't bumped that to stable yet. So technically, what you can do is on your cluster, you could go ahead and say Juju config Kubernetes worker channel equals 1.8 edge. I actually have no idea what would happen because so normally we don't push those to stable until we've tested them thoroughly, and then we push them to stable. However, there's nothing stopping us from trying it. So let me clean up a little here. So we have LXD. This is our LXD cluster running 174. Let's just try it. Juju config Kubernetes. We'll do master. Channel equals, what was it? Edge, right? 1.8 edge. This might blow up spectacularly, but that's how you would do it. So normally, like, we don't really, now that you know how to do it, if there's 1.8 snaps there, then go for it. You can deploy from edge and you can use that to play around. We normally don't make an announcement like, hey, CDK now supports 1.8 until we're ready to push it to stable, and we've tested it. But that was a great question. Okay, back to chat. How to use different CNI networking plugins. Yep, so we covered that. Canal, we'll add more over time, like Weave is another one. That will bundle so you can get it automatically. Right now you can get Flannel and you can get Calico and you can get Canal, which is Calico on top of Flannel. And if you're looking around, you're not sure where to get stuff, you can always just go to, like for example, I showed you that Canonical Kubernetes Canal bundle, and you might think, well, how in the world would I have found that if I hadn't been on this meetup? Well, you can just go to the Charm store and search stuff, and so there's that one. And if you click through, I'll just point out, it'll give you the command right here to deploy it. And then there's, I guess maybe we haven't published Calico yet. I mean, Canal is basically Calico. It's just Calico on top of Flannel. So you still get all the network policy support of Calico. So it's, in our experience working with customers, you know, Canal is a perfectly viable option. But we'll probably do a raw Calico one eventually. Let's see, what else do we have? In case of deploying it on AWS, where does the Juju controller gets deployed? Okay, so it's basically just another machine running alongside. So when you deploy on AWS, EC2 instances get provisioned, and I'll probably not be able to figure out where the controller is in this list, but it's basically just another EC2 instance that gets fired up. So it's there in the background when you tear down, so you can Juju destroy model, Juju destroy controller to tear down all of your stuff, and the controller will get cleaned up with it. One of the benefits of using the Juju as a service thing is that you can deploy models all day long using your own AWS credentials, but you don't pay the overhead of a separate controller that you have to run and pay for. So definitely, you can learn more if you go to jujucharms.com and click on About Jazz Juju as a Service. You can find out more about how exactly that works. Okay, next question. How to deploy multiple Kubernetes clusters, for example, separate master worker, variable number of master or worker nodes.
Yeah.
So,
Sorry, to elaborate on the question, because I just reread it and it felt pretty confusing. So the actual question intent was, so let's say I have like a couple of pre-provisioned VMs that I want to use for my whole cluster setup. Bare metal VMware VMs or some cloud, some VMs on cloud. The question is, can I specify which machine to be used as my master or as my worker node, and the respective number of those?
yes, you can. So let me show you how you would do that. Again, jujucharms.com. We'll go click on Docs, and the user guide. We'll click on Expand Clouds, and you got a couple different options for bare metal. Like if you're running MAS, then you should use that. But if you just have machines on the network with IP addresses, you can even use those as your cloud. So that's the manual provider. And if you read through basically this page, it will tell you exactly how you would do that. So you can bootstrap to a node, you can add machines to that Juju model via IP address, and then when you deploy, you would tell it which machines the individual components go to. So you remember earlier in the talk, we were looking at this bundle file. If you say Juju deploy Canonical Kubernetes, what happens is it comes out to the Charm store and it downloads this bundle. But you can